I hope y'all had a great Christmas. I miss seeing everybody. And since we can't be at school together, we can be together virtually. So I just wanted to say hi and tell you how much I miss you. I hope everybody had a great Christmas. I hope that everybody stayed well. And I'm ready to get started. So today what we're going to be doing is we're going to be starting a new unit. And this week and next week, we're going to be talking about unit rates. But today and tomorrow, actually this whole week, we're going to be talking about graphs. One is a distance time graph and one is a speed distance graph. And we're going to be talking about unit rates a little later this week. But today, to get our math brains working again, what I'm going to do is I'm going to introduce the distance time graph, and then I'm going to have you do 30 minutes in Excel on the diagnostic part so I can see how you're thinking about math and what I can do to help you further yourself along. So today we're going to talk about that distance time graph. So I want you to think about, when you look at graphs, what do you think you're looking at? And I know some, especially with a distance time graph, you may look at it and think that it's the path. So if you see a line going up, you may think that that means that you're climbing a hill. If you see a line going down, you may think that that means that you are going downhill. If you see a straight line, maybe you're just walking forward. So that would be an easy way to misinterpret a graph. You have to think about with graphs, what am I looking at? If it's a time distance graph, you're thinking about how far away you are from home and how long you were in certain places. If you're looking at a speed graph, you're looking at, of course, the speed. How fast were you going? So it's easy to look at graphs and misinterpret them as a path. So we're going to do a short little activity, and usually in class, if we were in class together, y'all would be doing this activity. I would ask for volunteers, but we're not in class, so welcome to my kitchen. So I'm going to show you what I would have you be doing in class. Now, most of the time we go out in the hall and do this, and I have someone walk for me just to kind of let you see what that would look like. But right now, what I want you to do is I want you to get a piece of paper and get a pencil, and I want you to draw my path. My path is, how was I walking? So I'm going to get up and go back here, and I want you to draw what my path looks like. So the first thing I'm going to do is I'm just going to walk a steady speed, and I'm going to walk a certain path, and I want you to draw that path. Okay, so if I start back here, and I'm going to walk approximately 8 feet, and I'm going to walk at a steady speed. And then I'm going to turn around, and I'm going to walk right back to my starting point. Okay, so I want you to draw that path. Okay, so what did that path look like? If you said a straight line, that's exactly what my path looked like. Now this time I'm going to walk a little bit different, and I want you to see, I want you to graph my path, graph what it looks like. So I'm going to go back to my starting point, start over. So this time I'm going to walk slowly 2 feet. And then I'm going to walk fast. And then I'm going to stop. Then I'm going to turn around, and I'm going to walk slowly. Now fast, stop, 2 slow steps, and turn around. Okay, so this time, did it look the same? Did your graph look exactly the same whether I was walking at a steady speed or if I was walking fast and then slow and then I stopped? Your graph should have looked exactly the same. It should have looked like a straight line. So I hope if yours didn't look like a straight line, That's okay, because we're going to be talking about graphs this week. I'm going to get a graph for us to look at and for us to kind of analyze, and I'll be back to you in just a few minutes. Okay, so here's our graph, and you'll be working with a graph just like this tomorrow, but I wanted to go over this graph today to just kind of get you started thinking about math again and to make some points about this graph before we actually do the activity tomorrow. So I want you to notice it's always super important to pay attention to what it says is going across the bottom and what is going up. So the bottom, or the X, is time in hours. Because remember, this is the x-axis and this is the y-axis. So when you list coordinates, it would be x first and y second. I know that's not new to you because every year kids come in and they know this part of it. So I'm not worried about that. Okay, and I want you to notice that your y coordinate is the distance from the home. Distance from where? Home. It's the distance from home. So I see that my graph starts right here. So my coordinate here is what? My coordinate here is 0, 0. So when t, or time in hours, is 0, I am 0 miles from home. So what does that mean? If your time is at 0 and you're 0 miles from home, that means you are at home. And your coordinates would look like 0, 0. Okay, the next one says time in hours is 1 hour. So when you are 1 hour from home, you are 3 miles from home. So your coordinates there would be 1, 3. So I should have already done this, but when you have a table like this, sometimes it's easy to just look at your graph, and sometimes it's easy to make a table. So this would be your x coordinate, and this would be your y coordinate. Time in hours is your x, and distance from home is your y. So when you put it in your graph, you can see those coordinates just right off the bat. Okay, well, when my time is 2 hours from home, if I go up, I can see that I'm 4 miles from home. When I am 3 hours from home, I am 8 miles from home. When I'm 4 hours from home, I am 5 miles from home. And when I'm 5 hours from home, I'm still 5 miles from home. And we'll talk about that in just a minute. Okay, I see that when I'm 6 hours from home, I'm 2 miles. And when I've been away from home 7 hours, I am back to the starting point. So I am 0 miles from home. So let's talk about what does this graph mean in context to my x and y coordinates. So if I look here and I'm 0 hours from home and I'm 0 miles from home, that means I'm at home. So I leave home and I'm go an hour, and in an hour I've made it 3 miles. Now, she must be walking because that's pretty slow to be gone an hour and you're only 3 ways from home, and she must be walking pretty slow at that. So, after she's been gone 2 hours, she's only 4 miles from home. So, in just an hour here, she only went 1 mile. So, she must have done some really slow walking, or she stopped or something, because she only got 1 mile. Okay? So, and when another hour passes from 2 to 3, she's gone up to 8 miles away from home. So she's really went 4 miles here. How did I know she had went 4 miles? Is at 2 hours she was 4 miles from home, And in just 1 hour, she went 1, 2, 3, 4 more miles. So she was walking really slow from here, but she went really fast from here to here because she got 4 miles in just 1 hour. So what do you think this means? From here, she's 8 miles from home. And then it says she's been gone 4 hours and she's only 5 miles from home. So even though she's been gone, she's closer to home than she was an hour ago. What do you think that means? If you said she's going back home, you're correct. So on this side of the graph, she's moving away from home. And on this side of the graph, she's returning or going back home. So we get here to she's been gone for 4 hours and she's 5 miles from home. And then an hour passes and she's still 5 miles from home. So this flat line means what? An hour passed and she's still in the same place. So maybe she stopped for lunch. It doesn't really tell us what she was doing during this time, but she stopped during this time. So this flat line means that she has stopped when you're dealing with a time distance graph. Time keeps passing, but she's still in the same place. She's still just 5 miles from home. Okay, so here another hour passes here, and she is only 2 miles from home. So she has went 3 miles in this time. She went 1, 2, 3 miles right here back towards home. And then 1 more hour passes. She must have got a little tired because she only got 2 miles in between here and here. So if I were looking at my graph and it said when was a time that she stopped, then I would look for a time where time passes but her distance did not change. If I were asked when was she moving the slowest, I would have to look. An hour passes, she went 3 miles here. An hour passes here and she only went 1 mile. Another hour passes and she went 4 miles here. An hour passes, she went 3 miles here. She went nowhere here. So from here to here an hour passes and she's only went 3 miles. And from here to here an hour passes and she's went 2 miles. So when I look at this graph, I can see that only an hour passed here and she only went 1 mile in that hour. Because she only went from 3 miles to 4 miles. So that equals 1 mile. So I would say her slowest, when was she moving the slowest, would be here. Now some of you may have said here. But why would that not be the correct answer? If you said because it asked when was she moving the slowest, you're correct. She was moving here. She was just moving slow. Here, she didn't go anywhere. She was still 5 miles away from home. So she was stopped here. So that would not count as when she was moving the slowest because she was not moving. Now the second slowest time would be here because she only moved 2 miles here. So sometimes I have children pick here. That's not correct because there's 2 miles here where there's only 1 mile here. I think they look at this and they think they're looking at a mountain. So they look at it as, oh, well, she was climbing uphill here. And then there was a little bit of an incline. And then it was a straight up. And then she starts going downhill. That's not the case. This is not her path, which is why we did our path video earlier. I wanted to show you that no matter her speed, the time lapse here, she was still not walking up a hill. She was walking there and walking back. So she left home and she returned home here. When her coordinates were 0, 0, she was beginning from home. And when her coordinates were 7, 0, she had returned home. Now, if I looked at my table here, I could easily see when was she at home. It says miles from home here. When it's 0, she's at home here. And 0 here, she's at home here. Because y is distance from home. When you're 0 miles from home, that means you're at home. Could I look at my table and see when she was stopped? I could, because her distance from home here stayed the same. So here is where she stopped. Okay, there's lots of different things you can do with graphs and tables, and you can make both of them with any graph. You can form your own table, and you can also read it different ways. So that is today's lesson. Tomorrow you will be working with a graph and answering questions based on your graph. So I hope that this helps. All right, I hope y'all have a great day. And I need you to do 30 minutes on diagnostic in IXL for me today. Make sure you get that 30 minutes in. All right, have a great day, and I'll see you tomorrow.